Yes, here we'll continue with the last problem. The problem is like this. This is 10. Here values are given as, see, 5 volt, 4 ohm, 5 ohm, 2 ohm, 10 volts, and 1 ohm. Okay, and this one is 1 volt. Okay, I can make it 1 volt. Now, question is find the current in the 10 ohm, find the current in 1 ohm resistor. Okay, here we need to find the current in this 1 ohm resistor. Okay, first step is what we need to, yeah, tell me. Norton theorem, if you find the current in
short it.
this one, no, we need to short this one. Okay, now I'm going to short this 1 ohm. I'm going to short to find the current in that. Okay, now I shorted this. Mark the terminals, the terminals A and B. Then mark I way and mark the current IN. Okay, now you can see in this figure that the 5 volt and 4 ohm are in parallel, and one more, this short circuit AB branch also in parallel with 5 volt resistance. So whatever the current through this 5 volt resistor, it will bypass this 4 ohm resistance, then it will flow in the other branches. It means always current will find a path with the low resistance. Here short circuit path. Okay, so this 4 ohm resistance will is a useless now, that is redundant. This 4 ohm resistance will become redundant because it's connected across the 5 volt resistance, and we shorted this 1 ohm resistance to find our short circuit current IN. So my circuit will become like this now. Okay, see here, 40 volt, this 4 ohm, 5 volt, 5 ohm, 2, 1. Okay, here, sorry, here this is short terminal A, B. Okay, and this is 2 ohm, this is 1 volt, this is IN. Okay, 5 volt, 5 ohm, this is 4 ohm. This will become useless now, redundant, because we shorted this one. Current will, now we are going to consider these loops, loop 1, loop 2. 2 loops, I1 and I2. Okay, now apply yes, tell me loop 1. Apply KVL for loop 1. I1.
minus
Yes,
5 I1
minus 5
I1
I1
minus 2 I1 uh plus 2
minus
I2
2 I1 minus I2 plus to minus minus 1 volt,
and
then plus 5 volts equals to 0. Correct? Yes?
yes sir.
Yeah. If I simplify this one, I'll get 7 I1 minus 7 I1 minus 2 I2 is equals to 4. I call this equation as 1. Just check this equation is correct or not. Minus 2 I1 2 I2 then plus 4. Yeah, it's correct only. Now apply KVL for loop 2. Apply KVL for loop 2. Yes, tell me.
One minus 2 I2
Minus
Sir,
2
1 minus 2 I2 minus
2
I1
I2 minus I1
I1 equals to
0.
yeah. Now simplify this. I1 minus go that side.
Sir, 2 I2 minus
Yes,
I1 equals minus 1. Sorry, equals 1.
2 I2
Minus I1 equals 1.
minus I1. 2 is there
minus
here, right?
2 I1 minus
Minus
2 I1
2 I1
Equals
equals
1.
to 1.
1.
Yes, I will call this equation as 2. Now solve this equation 1 and 2 and tell me the answer for I1 and I2. Solve 1 and 2. I1 equals to how much? I2 equals to how much?
Sir, I1 is 0.6. No, no.
0.6.
1 second.
0.6. Check once.
sir
no
I1
sir
is equal to
point
1
Yes.
Oh,
I1
sir,
is equal
1,
to
sir. I1 is 1.
I1 is 1, sir. I1
I1
is
is
1.
1
1
is 1, I2
ampere.
is 1.5.
I2 is 1.5.
1
I1 is
point.
equal to 1, I2 is 1.5.
I2 is 5 ampere.
1.5, sir.
1.5 ampere. Okay. Now we can see I2 is in same direction of IN. So I can call IN also 1.5 ampere. Okay. We found out IN. Now next step is we need to find the RN. For finding the RN, we need to short the voltage source. Yes. Then one more voltage source is there. We need to short this one. For finding Rn, you need to short both the voltage source. Okay. Now this one is point A, point B. We need to find Rn. Okay. Tell me Rn. By seeing this figure, okay. 5 and 2 are in parallel first. 5 in parallel with 2. How much? I can say 40 and 4 and 2 are in parallel first. Just calculate Rn and tell me. Yes. Waiting for your answer.
Sir, 6.33.
How you calculated?
Sir, 1.6.
1.6.
636.
See, we need to calculate the Rn from these two terminals, A and B terminals. Okay. Now we can see 5 and 2 are in parallel.
Okay,
Here.
sir, got it.
We need to consider only 5 and 2 in parallel. Whenever we are seeing from terminal A and B, okay, this is short circuited. Now Rn will become 5 in parallel with 2. So Rn will be 1.42 ohm. Okay, next step, need to draw a equivalent circuit for Norton equivalent circuit. See here, we found the IN. Okay, then we found Rn, that is in parallel resistance. Then we need to replace that 1 ohm, that is RL. Okay, here this is IN, this is Rn, this is RL, this is point A and B, where in the question they are given one current through 1 ohm resistor. Okay, we replaced that one with a short circuit. Here this is 1 ohm. 1 ohm. This is Rn is 1.42 ohm. IN is 1.5 ampere. This is IL current. Now we need to find the current IL. By current division rule, total current 1.5 into opposite resistance 1.42 divided by sum of the resistance, that is IL equals to 1.5 into 1.42 divided by 1.42 plus 1. Yeah, tell me. That become 1.5 to
0.88.
1.42.
0.880.
Yes, 0.88.
0.88.
Yeah, 0.88 ampere. 0.88 ampere. Okay, now everyone understood this problem, right?
What
Yeah.
are the four resistors?
See, that's what. Here, if you are seeing the resistance Rn from points A and B. Okay, here it's a short circuit. This will become a redundant. So we are need to consider the resistance 5 and 2 which are in parallel. We need to see resist across A and B. Means viewing from the points A and B, we will only get 5 and 2 in parallel. If it is not short circuited, then we are going to consider this 4 ohm. Okay, see here if it's not short circuited, then I am going to consider all three resistance. Now we have this, because here one voltage source will be voltage source was there before, we short circuited that one. Here also one voltage source was there. Okay, if this one is not short circuited, then I am going to consider Rn is equals to, if it's not there, if it's not there, I am going to consider this one. 5 and 4 in series, 5 plus 4 is in parallel with 2. This is the case where this branch is not there. Okay, understood? Yes.
Yes, sir.
Yeah. Now we'll see a problem on with dependent sources. Okay, now before in the questions they are going to mention whole means what you call closed circuit or closed network, they are going to mention for this Norton. Here for dependent source the circuit will be like this. See, 5 volt, yeah, tell me dependent sources are drawn with a circle or diamond? Yes, diamond
Diamond.
shape. Then here one more dependent source, then one resistance. Okay, now they are given this point A and B. This is 3 I1 10 ohm minus plus 5 ohm plus minus 10 I2. This is 10 ohm, 5 volts. Okay, in question they have given this current as I2, this current as I1. Okay, now they ask find equivalent network across the terminal A and B. Find Norton's equivalent network across terminal A and B. Okay, first, how many loops are there? Yes, by seeing this network, we can easily tell how many loops are there.
One.
One loop, because these A and B are open circuit. In question only they are given this one as a open circuited, so we need to find VTH for our Rn. Now, okay, we'll see while solving the problem. Here one loop is there, so one loop current. Okay, I'm going to mark this one as I3, or we can name this I3 as IX or IA, whatever, just naming is different. Okay, I am marking this loop current as I3. I2 is the branch current, I1 is the branch current, I3 is the loop current. Okay, now we can say from this figure that I3 or I2 is equals to I3. See here, this I2 is equals to I3, same current, right? Okay, now I1 is equals to, see, opposite to this, minus I3. Correct? Understanding? In question itself, they are mentioned the branch currents. Only one loop is there. That loop current I am going to mark it as I3. Here I3 is nothing but I2, means equals, same current. I2 equal to I3, where the I3 will flow in this branch, that is I1. This is opposite to that. I1 is equals to minus I3. Okay, understand? If you say yes only, they will continue.
Yes,
sir.
sir.
Yeah, now apply KVL to this mesh. Apply KVL. Apply KVL to this mesh. Yeah, minus to plus, plus 5u.
minus 10 I3.
Minus 10 I3. Now first before that I will mark current entering into this point, plus minus. Okay, current this I3 entering into here, plus minus. Okay, now tell me, plus 5u. Okay, minus 10 I3, minus 5u I3, then plus to minus, minus
minus 10 I.
10 minus 10 I2 is equals to 0 for this loop. Okay, current entering into marked at a plus minus. Okay, we are writing this KVL equation with the help of loop current. Plus 5u minus 10 I3 minus 5 I3, here plus to minus 10 I2 is equals to 0. Now we know I2 is equals to I3, I1 equals to minus I3. Replace this 2 in this equation, I'll get 5u minus 10 I3. See, I'll solve this one. 10 I3 and 5, that is 15 I3. I2 we have to replace with this I3, that is minus 10 I3 equals to 0, that is 25 I3 minus 25u I3 equals to minus 5u, that is I3 equals to how much?
0.2.
0.2
2.
ampere. I3 equal to 0.2 ampere. Now what is the value of I1? Value of I1,
Minus 0.2 ampere.
Minus
Minus
0.
0.2 ampere.
I1 is equals to minus I3, that is minus 0.2 ampere. Okay, now we need to write the open circuit voltage equation here. If in the question paper they ask like this problem, in the sense this open circuit, this one, first we need to write the loop currents equations. From that we need to find branch currents. Okay, after that we need to find this open circuit voltage, that is VTH, because we know that RTH is equals to VTH by IN. Okay, RTH is equals to VTH by IN. Open circuit voltage divided by short circuit current. Sorry, this RN. For that, write the equation VTH. We need to find this VTH. Okay, now we can see VTH is equals to equation for VTH. This is okay. VTH is equals to tell me, or equation for VTH. I'll simply write here equation for VTH. Now consider this. By seeing from terminal A and B, we need to write the equation for VTH. Consider the path. Okay. 5U, see here. VTH nothing but the open circuit voltage A and B. 5U minus 2 plus 5U. Then plus minus 10 minus 10, then minus 2 plus 3 I1, then here plus to minus VTH equals to 0. I am considering this B to A path. Now you have one doubt in your mind that I apply the KVL at the outer path to find the VTH, but I didn't consider this a 10 ohm resistance. Have you observed that one? Why? Yes. Or you only tell me if write the equation like this for my VTH, or else simply this is the thing. I am writing the A. Okay, from A, I am writing the yes. In this path, okay, minus 2 plus 5 plus 2 minus 10 I. Then coming to this minus 2 plus, that is plus 3 I1. Okay, then okay, I neglected this. Then coming to this minus potential drop minus VTH. Is any logic in that? If why I am not considering this 10 ohm? Yes. Anyone? At least
We don't know what current is flowing, sir.
here open circuit is there. There is no current flowing it to 10 ohm. So if I consider this one, there is no current in the sense if this I is, then voltage drop. See here, if I'm going to consider the step, okay, current is not flowing. Okay, then 10 into current is not flowing because open circuit 0 minus, that is minus VTH equals to 0. So I didn't consider this minus VTH equals to 0. Okay, we know now I3. I'll write here 5 minus 10. This one everyone understood, right? Why I didn't consider this 10 ohm resistance? Because voltage across this 10 ohm resistance is 0 because there is no current flowing through this 10 ohm resistance because this is the open circuit. Everyone got this right?
Yes, sir.
Yeah.
Yes, sir.
I3 we know I3 is 0.2 plus 3. I1 we know minus 2 minus VTH equals to 0. Yeah, tell me what is the value for VTH? 5 minus this is 0.2 minus 2. VTH will be how much?
2.4 volt.
2.4 volts. VTH is 2.4 volts. Okay. For this Rn, we have calculated VTH. Okay. Now we calculated branch currents I1, I2 and loop current I3 and calculated open circuit voltage VTH. Okay. For drawing the equivalent network, that is not an equivalent, what we required, which current we required,
IN.
IN we required. Now we need to calculate IN. This one I'll just remove. Okay, I'm going to write, draw a circuit, this circuit for calculating I 5 volt, this is 5 and dependent source minus plus, this is minus plus 10. Okay, across AB we need to calculate the Norton equivalent, where this is point A and B. Here this is point A and B plus or minus. For calculating IN, I need to short circuit this terminal A and B. Okay, now then I need to mark the current IN on that short circuit IN. Okay, here it's given as I2, this is given as I1, 10 ohm, 5 ohm, 10 I2, 5 ohm, 3 I1 and 10 ohm. Okay, for calculating IN, I need to short circuit A and B. Okay, now how many loops are there now? In first circuit, one loop. Here in second circuit, two loops. Okay, this one I already marked that I3. The next one I am going to mark this one as I4. Plus minus. Here plus minus plus minus. Okay, now apply KVL for loop 1, loop 1, loop 2. For loop 1, apply KVL for loop 1. Yes, fast. Plus 5 minus 10 I3, then minus 5 I3 minus I4, then plus 2 minus minus 10. I2 is nothing but I3. I3 equals to 0. Okay, now simplify and tell me. Fast. 5 I4 equals to 0. I call this equation as 1. Okay, now I KVL for loop, this loop. Yeah, plus 2 minus 10I2, that is potential gain 10.
Sir,
I2
first
is
equation
nothing
equals
but
to 5, no, sir?
which one?
Yes, sir. First equation
Yeah,
Equation
is
1.
equal to 5.
yeah, yes, this one is 5. Okay. Now next. Now KVL for loop 2. 10 I2, that is meant I3 to equal to I3. Then coming to this minus 5 4 minus to plus 3 I1 is nothing but my I1 equals to minus I3 sorry, see here, correct only, minus plus 3 I1 minus I3, that is next minus 10 I4 equals to 0. Yeah, now tell me, simplify and tell me, 10 I3 minus 5 I4 minus I3 plus 3 into minus I3, then minus 10 I4 equals to 0. Yes. First
12I3 minus 15I4 is equal to 0.
yes, 12 I3 minus 12 I3 minus 12 I4 only.
15.
Check once.
15, sir. 15 I4.
See here, 1 minute. 10 I2 minus 5 I4 minus I3. Here, see here, this is I1, correct? This is I1. Okay. Here, this is open circuited, so I1 equal to minus I3. Now it's short circuited, closed circuit. Now this I1 will become I4 minus I3. I didn't mention this one. See here. This is open circuited, so I1 equal to minus I3 for loop this one. Here, I short circuited this one to calculate the IN. Now this I1 become I4 minus of I3. I1 and I4 are in the same direction. So I4 minus of I3 is opposite direction of I1. So I1 equals to I4 minus I3. Now I can write this I1 as see I4 minus I3. Yeah, now tell me.
Sir, I3 is 0.25.
No. Solve this one. Solve this equation and simplify form I want.
That will come, sir. 12I3 minus 12I4 is equal to 0.
Yes. 12 I3 minus 12 I4 equals to 0. Equation 2. Yeah. Tell me the values for I1 and I3 and
Both are 0.25.
yes. 0.25 ampere and 0.25 ampere. This is for IN. We know IN is equals to this IN is equals to I4. This is IN. I got 0.25 as my IN. Now calculate the RN. See here. Need to draw equivalent circuit IN and A, B, RN, IN. Okay. Now we calculated IN equals to 2.5 ampere. Okay, we know this open circuit voltage VTH is equals to how much? 2.4 volts. Now we need to calculate this RN. That is RN is equals to VTH divided by IN. That is 2.4 divided by 2.5. Sorry, 0.25. This is 0.25. 0.25 is equals to how much?
9.6.
9.6 ohm. 9.6 ohm. Okay. Now I draw a Norton equivalent diagram as this is nothing but the Norton equivalent. I'm just simply redrawing that one. This is my Norton equivalent circuit AB 9.6 ohm. This is 0.25 ampere. This is my Norton equivalent circuit. Understood? Yes? Now you are able to solve
Yes.
the problems with dependent as well as independent sources, right?